Welcome back. Let's have a look at another example of finding the equivalent capacitance of a relatively a complex circuit. Okay, so this is a capacitive network and all capacitors are basically 4 microfarad and we need to find the equivalent capacitance. So basically the capacitance between these two nodes. Okay, so all are 4 micro, like this is 4, this is 4, 4, 4 and 4. Okay, our approach will remain same. Okay, first off, label the nodes. Okay, so if you look at the nodes, okay, I noticed that this is a complete one node, that is basically, let's label it as A. This is one node, that's labeled as B. This is another node. Okay, and this node is basically what? This is the same node, right? And this is my node C. Okay, so if we do the labeling like this one, everything will become quite easier. All right, now let's have a look at the circuit and see what we can see. All right, let me start with the last end of the circuit. If I look at this branch, which is sharing node A and C, okay, this 4 microfarad. This is connected between node A and C. And if I look at this branch, this is also connected between node A and what is the second node? C, right? So it means they are sharing two nodes. If they are sharing two nodes, it means they are in parallel. So if they are in parallel, what will happen? Okay, 4 plus 4, it will become 8. So can you just redraw the circuit like this one, and this will 4 and 4 8, and this will become between A and C, right? So between A and C I have a capacitor of basically 8 microfarad, right? Then what is the left? What is the rest of the things? Let's just redraw the rest of the things. So I have this another, okay, this one 4 micro. Okay, then I have a node B basically here, and with the node B, okay, we have a capacitor of basically 4 microfarad, and this is basically connected at node C, okay, the same node. Okay, and then we have this last one here. This is also basically connected between B and C, okay, the same node here. This is again, of course, 4 microfarad. Now what is the next thing that you can notice here, which will be in parallel or series? So if you look at the nodes, like this is node B, so this capacitor is connected at node B, and the second end is basically what? Node C. This capacitor also connected at node B, and second end is basically what? Node C. So it means they are also in parallel, right? So what will happen now? So this 4 and this 4, this will become again 8, right? So if I further redraw this circuit to the next step, so that will be basically, I have the last one, okay, 8 microfarad. Okay, between A and B, I have this 4. Now between B and C, this 2 become 4 and 4, 8, and that will be basically connected where? Between B and C. Okay, like this is point C, okay. So between B and C, we have another capacitor, okay, that will basically will become 8 microfarad. Okay, now if you look at this one, okay, this 4 and this 8, they are in basically series. So that will basically, if I write now the equivalent here, so these two are in series, so that will be 1/4 plus 1/8 inverse, right? Then whatever I'm getting here, that is in parallel with this one. So parallel means just add them. Okay, so if we just add them together, our answer will become 32/3 microfarad. Okay, so this is how we can basically calculate the equivalent capacitance for this circuit. Thank you so much.